I feel like I'm a big red fat man. Sports fans and nerds alike, I am Cleet Callahan. This is the 4th episode of Baseball Physics, and will I tell you how to hit a dinger? I don't know yet. It's important to realize that the Earth's gravity has the strongest effect on a ball being hit into the air, because the mass of the Earth is pulling remarkably strong on that little old baseball. How strong is that pull? Well, it's easy to figure out because of our good old pal, Mr. Newton. You see, if you're suspended in the air, like as if you jump off of a diving board into a pool, the Earth pulls you down. But believe it or not, you actually pull the Earth up with you as well. Mind blown if you didn't know that already. If you did know that already, appreciate how cool it is. Okay, so the equation to figure this out is if you have the mass of two objects, okay, multiplied by big G, all of that divided by the radius squared, or the distance between the two objects squared. In other words, F equals big G times mass of 1 times the mass of 2, all divided by radius squared. What is big G? Little g, if you didn't know, is the acceleration due to gravity, 9.8 meters per second per second. It's the acceleration we experience in free fall due to gravity in a vacuum. Big G is 6.67 times 10 to the negative 11th Newton meters kilograms squared, or I don't know how to pronounce it actually, to be honest with you, but that's what it looks like. Okay, so essentially, if the variables that are not big G are known, big G will always be this very, 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 very small number, 0.000000000068. The mass of the Earth. That's 5.972 times 10 to the 24th kilograms. That is big. What's the radius squared? Well, looks like we needed to take a bit of a tangent here in calculating height. So I dug around the internet and I found these formulas here. Velocity XO is the horizontal initial velocity. Velocity VYO is the vertical initial velocity. VO is the initial velocity. Let's rephrase it. A baseball's hit at an angle of 35 degrees with a velocity of 46.48 meters per second. Find the max height, the time in the air, and the total distance traveled. 4648 times 0.819, which is the cosine times the launch angle, and that equals 38.07 meters per second. 46.48 meters per second times 0.574, which is the sine of the launch angle. Can you not tell that I'm cheating right now by looking at my notes? That equals 26.68 meters per second. The max height that we are looking for is essentially when the vertical velocity reaches 0, because it's not going up or down. The only acceleration acting upon it vertically is gravity. This position occurs when the velocity on the y-axis is 0. T equals vertical velocity divided by g. The variable there that we don't know is t, so let's solve it to get more information. 26.68 divided by 9.8. Okay, that is 2.72 seconds. The ball is in the air for 2.72 seconds before it reaches the highest point. The variable y is used to denote height, and since that's the position on the y-axis, the formula we'll use is v equals the vertical initial velocity times t minus 1/2 acceleration due to gravity times time squared. So y equals 26.68 times 2.72 minus 1/2 times 9.8 times 2.72 squared, which equals 36.22 meters, just under 120 feet. That's how high the ball will go. So let's now go back to our gravity problem. The force that the Earth exerts on the baseball and vice versa, F equals G times 0.145 times 5.972 times 10 to the 24th divided by 36.22 squared. Hey, sports fans, I just realized I made a huge error in this gravitational equation. You see, r squared is the distance between centers of masses of two objects, not the height of one object off the ground of the Earth. I am so stupid. So basically, the radius of the Earth plus the 36 meters the ball is above the ground, that will be our r squared. So we'll go back to the video and you will see that I will make that change. Okay, so I just did the math myself. It turns out that the force exerted is 4.059108 times 10 to the 13th newtons. That is a 405,910,080 with an additional 13 zeros after that, newtons. Whoa, back to the show. That is so fun. But what does it have to do with our ultimate equation? Nothing. It's just fun to think about. Anyway, I know. I owe you an answer. Well, we need to know how long the ball will be in the air total. Well, we figured out before that it's 2.72 seconds to get to the highest point, so just multiply that times 2, right? Wrong! Wrong! Idiot! Okay, so now we can use the same equation that we just used, but this time we know that y equals 0 and we want to solve for t. And using some algebraic manipulation, which I had to do online because I'm not that good at that kind of stuff, we find that t equals 2 times 26.68, all divided by 9.8, which equals 5.44 seconds. So the total time in the air will be 5.44 seconds from point A to point B. So it's important to differentiate between horizontal time and vertical time. So the time it takes for the ball to reach its highest point is 2.72 seconds. The time it takes for it to reach its furthest point is 5.44 seconds, okay? Great. Okay. The moment we've all been waiting for. The formula to find the distance the ball will be from the moment of impact to the point where it lands. Crap! We forgot to take into account the height of the ball when it hits the bat. It's not going to be hit off the ground. Bleh. All right. Well, you know what? Assuming that the ground is totally flat, the height the pitch is thrown matters. That height is, let's say, 1 meter off the ground. If we draw a right angle from the moment of impact using geometry, we can get generally the place where the starting position of the ball would be if it were on the ground. So the ball's starting point is actually 1.43 meters further away than the initial point of impact. But honestly, let's just ignore it for the sake of our sanity. Gosh, I've been doing this for a long time. This being this video, not physics, clearly. All right, so if we're going to ignore that, now is the moment we've all been waiting for. Yes. The formula for finding the x is the velocity of the horizontal times the time that we found. 207.1 meters. Converting that into feet, we have 679.46 feet. I did something wrong. Psych! We're talking about a vacuum, remember? Why am I yelling at you? We're friends. So this isn't a vacuum. We don't have wind resistance. We're not taking into account the bat speed, the ball spin, or other crap like that, like air density, elasticity. We're ignoring all that stuff. This distance is right. If we were in a vacuum with the parameters that we set, the ball would travel almost 700 feet. So in a vacuum, you could hit it like a mile. Wait. Could you actually hit a ball a mile? Tune in next time. We're going to find out how hard you have to hit a ball to hit it a mile. That's right. This is Baseball Physics. I am Clete Callahan. Thanks for tuning in. Make sure you hit that subscribe button. Make sure you hit the thumbs up and comment below with something that you want to say. And then also follow me on Instagram, Twitter, and Facebook at Clete Callahan. And if you want to watch me play video games on the internet, watch me on twitch.tv/playbyplay. Again, my name is Clete Callahan. We'll see you at the ball game or in the classroom or wherever, someplace you want to hear me yell at you. Goodbye.